When solving a quadratic equation that's not factorable, our usual go-to method is using the quadratic formula. We know what the quadratic formula is. We know how to use the quadratic formula. We just use it to solve for the value of x, and we move on. However, have you ever wondered why the quadratic formula looked like that? Well, let me show you why the quadratic formula looked like what it does using the completing the square method. For those of you who are not familiar with the completing the square method, please check out my Algebra 2 lesson number 19, where I show in detail how to solve an equation, a quadratic equation, using the completing the square method. Let's begin. First, I'm going to subtract c so that I have only the ones with the x's on the left side of the equal sign. Next, I need to make the coefficient of x squared be 1. So I need to get rid of that a. To do that, I'm going to divide by a. If I divide the x squared by a, I need to divide the rest of the equation by, you're right, a. Like so. And if we simplify this, we get that. Following the completing the square method, what we're going to do is take the coefficient of x, b over a, and then we're going to divide that by 2. If you simplify that, you'll get b over 2a. When you're dividing a fraction by a number, the shortcut is to take that number, multiply to the denominator. Next, we'll take that b over 2a and square it, where it's going to be b squared over 4a squared. We'll take that and put it in here. If you add a b squared over 4a squared on the left side of the equal sign, we better do the same on the right side of the equal sign. Next, we're going to factor this left side, where it's going to be x something, parentheses, square. Since we're using the completing the square method, if we factor the left side, it's always going to be in that format. Only question is, what goes in here? You could either go ahead and factor this, or use this shortcut method where this blank spot will always be filled with this right there, b over 2a. Or half of the coefficient of x. So this little shortcut will help you factoring the left side of the equal sign, which of course equals this. And then we're going to subtract or combine the two fractions on the left side. And in order to do that, we need a common denominator, where the common denominator is going to be 4a squared, which means we need to multiply the denominator by 4a so that we would have that 4a squared, and of course the numerator as well. If we combine these two fractions, now that we have the same denominator, it's going to be 4a squared on the bottom and b squared minus 4ac on the top. To solve for x, we need to get rid of that square sign. Our usual method, take the square root, take the square root. Where we're left with x plus b over 2a without the square sign equals, since we took the square root of the left and the right side, we need to go ahead and add that plus minus. like that. Next, in order to simplify that square root, what I like to do is rewrite it so that we have a square root on the top or the numerator and another square root for the bottom or the denominator. Like this. So remember, when you have square root of a fraction, you're able to rewrite it as two separate square roots, one for the top and one for the bottom. What do you get when you take the square root of 4a squared? You get 2a. Now we're almost done. Now we'll go ahead and take that b over 2a, bring it to the right side, or subtract. There you go. Our one last step is going to be combining these two fractions into one, and that's not hard since we have the common denominator or same denominator already. There you have it, folks. We have our quadratic formula where x equals minus b plus minus square root of b squared minus 4ac all over 2a. Now you know why we have a plus minus sign here. And of course, that's because we took the square root on the left and the right side. And you also know why we have a 2a, not just a. And we have a negative in front of b. And also the reason for having that b squared minus 4ac inside the square root. When you understand how a formula comes about, it makes it much easier to memorize it. As you can see, deriving this formula, the quadratic formula, using the completing the square is not an easy task. Neither is using the completing the square solving a quadratic equation. Hence the reason we use the quadratic formula usually when solving a quadratic equation that's not factorable.